Welcome to the Microscopists, a bite-sized bio podcast, hosted by Peter O'Toole, sponsored by Zeiss Microscopy. Today on the Microscopists.
Today on the Microscopists, Ammasi Periasamy talks about his humble beginnings in India before founding the Keck Center.
In my home, I was a guest. All the time, high school also, I was not in my home. I was in my uncle's house because there was no high school in my village.
Adjusting to the culture of the USA after moving from India.
Adjusting with the people, yes, there was an issue, As you know, in India, you give respect to the elders, whatever they say, even it is wrong, you listen.
And his toughest times in academia.
The first time in the academic life, always getting grants, right? That is the toughest time for sure.
All in this episode of the Microscopists. Hi, I'm Peter O'Toole from the University of York, and welcome to this episode of the Microscopists. Today, I have a special guest of Ammasi Periasamy. Ammasi, how are you today?
I'm doing okay, great.
So, you won't remember this. You definitely won't remember this, but I remember meeting you in 2002, 2003, in Genoa at Focus on Microscopy that was organised by Albi.
I think it is 2004.
Was it 2004?
Yeah, I think so. 2001, 2002, we have the COVID, right?
Oh, sorry. No, 2000, 2003, 2004.
Oh, I see. Yeah. Okay, maybe. Yeah. All right. Yeah. I don't remember. Okay.
So as a young PhD postdoc that was doing FRET work at the time, I used to follow a lot of your posts on the confocal listserv.
Okay, yes.
Especially when I was sort of learning the ropes, as it were, back then. And I moved to York and went to Focus on Microscopy and got very fortunate. I think it was Patrick Courtney from Perkin-Elmer that introduced us, and we had some dinner.
Oh, I see. Okay. Mm-hmm.
So it is a pleasure to meet you again. So I don't think we've come across each other again since then.
Yeah, we do not. If you come to the SPIE meeting or Focus on Microscopy, we can meet. Otherwise, I do not travel much. Only these two conferences I do not miss. I always try to attend.
Which would be FOM and
SPIE. Yeah. SPIE I cannot miss because I am organizing the Multiphoton Microscopy Conference. I have to be there. I am the chair.
You see, that was one of my questions. Usually, it's what is your favorite conference?
I would say SPIE, Multiphoton Microscopy. No choice. And second one is FOM, for sure. I love that meeting, particularly if it is in Europe. You see a lot of exhibits of new instrument, new approach. I really like that microscopy, new developments and things like that.
So we'll come to the multiphoton side in a bit, but you're currently at the University of Washington, I think.
Yes. No, University of Virginia.
Oh, sorry, Virginia, in Washington.
In Charlottesville, close to Washington, about 2 hours drive.
When did you move over to the US?
Oh, a long time ago. It's 1985 or 86.
Wow. Okay.
Yeah, as a postdoc, University of Washington, Seattle.
And so if that was back in 86, I presume, therefore, you studied in India before?
Yes. My PhD is from Indian Institute of Technology, Madras.
And so,
in biomedical engineering.
Why the move to the US?
Well, I have a lot of interest when I was I'm basically a physics in master's in physics. When I was a student, I used to think about the time result, the lifetime measurements all the time. They teach, and at that time you have only exponential decay. I wanted to do something new, so I had the opportunity. I was actually working as an assistant professor in the local university after my PhD. And as you know, in India, getting job is not easy. And if you get a better job, they don't want you to leave. But I always try to advance my research activities in a better way. So when the opportunity came in, at that time, the head of the Department of Physics, where I was teaching on medical physics, and he suggested me, you have a great potential, you should go to US. I had 4 offers to select, and then I chose in the University of Washington, Seattle, and I came on, slowly I changed. There I built a polarization microscopy for investigating the cardiac muscle fiber contraction. That really led to me to involve in microscopy development, new ideas to solve new questions involved in biological and as well as clinical applications. So that's the reason my interest is always in science. I wanted to do something new, application side, not in pure physics. That's why I changed to biomedical engineering.
You just preempted my question of how did you, as a physicist, why did you go into addressing biological questions or using your physics to develop tools to better address biological?
That's correct.
Why biology?
Yeah, physics is, all the system based on physics. Either biology, you really understand, if you have a physics background, how it works. And on the instrumentation side, the physics is the big engineering side too. My father told me, why don't you go for engineering? After I passed in the high school or pre-university, and I told him I want to be a scientist. Okay, cool. So that's how I involved in science. Since high school, I have been more motivated to do something positive, something benefit to the society. So you learn something, teach the students whatever you learned, and things like that. I have that kind of motivation. That's why I started the workshop on Fred microscopy and running a conference, things like that. So that is the motivation why I decided from physics, pure physics, to applied area.
So your father was obviously a clear inspiration to you in that aspect, and pushing you into a sort of science, not pushing you, but inspiring you to go onto a science.
Yeah, I mean, that's the way they do that, right? I tell my son, hey, why don't you study this? But he said, no, I want to go for aviation engineering. Okay, that's how it goes. No, he went to aviation engineering. So I recommended him to study biomedical engineering. That also you can go to NASA. Any degree you study, if you do well, you can go to NASA. That's not a problem. But he decided to go for aviation engineering the same way me. I want to be a scientist. So, okay, go for physics. So that's what I did.
Do you just have the one son? Do you have any other family, children?
I have one son and one daughter. Daughter is a radiologist working in my university hospital. And my son is an aviation engineer. He was working for NASA for a couple of years, and then he went for system engineering, and he said he's planned to run his own company. So whatever he wants to do, it's okay.
So both are scientists. What about your partner? Is she a scientist as well?
No, I came from, my father is a farmer. I came from a village, and I was the only graduated person from my whole society. I would say maybe, my father is head of the village. What do they call it, as a president or something like that. So yeah, until he retired, he was. And same as my grandfather. So all are farmers, and they are all kind of leaders in the village. And so I studied well. My father's philosophy is, I have a brother and sister, but my brother always fails in his exam, even in the elementary school or high school. Actually, final high school, he failed. My father idea is that if you fail, you have to come and take care of the lands. You should not continue. So I was always first in the class in everything, high school. So he allowed me to go further and further. So that's how I continued. And he did not push me. I just tell him, okay, I finished my BSc Physics in first class. I want to go for master's. He said, okay. So that's how I continued all my education.
So it's a very different childhood then at
Yes.
that point.
Yes.
So can you recall when you were probably around the age of 9, 10, you probably started to think about what you may want to be when you grow up? So before your dad said go into science, what sort of job did you imagine yourself doing? The first job you can ever remember thinking, oh, I'd like to do that?
I always, in the high school, they asked me to write an essay. The same question, what do you want to be? I wrote, I want to be a scientist. It continued. It was in my system. I continued. You see my career. I after my master's degree in physics, I got a job as a demonstrator in the engineering college. And I went and joined in the IIT Madras as a PhD student in biomedical engineering. They told me that I have to do masters in engineering too, because if you go from science to engineering, you have to do one more master's degree to continue your PhD. So I did that. Then again, I got a job after PhD, and again I came to this country. So it's always my motivation is doing something new. Still, I am doing the same thing. All my research, if you see publication, I always did something new and then move on, advance, using my basic ideas. And I moved on for all the time. I always focus on research. Yeah, that's true.
So I'll take you now back to when you were probably 16, 18. You said you lived in a village, a farming village itself.
Yes.
It must have been quite a big change going to Madras, which is now a big city, a very large city.
Yeah.
How did you find that culturally? How did you find that change, that transition?
Yeah, to my home, I was a guest. All the time, high school also, I was not in my home. I was in my uncle's house because there was no high school in my village. So I was studying well. So my uncle took me to his house. So I was going to the little bit of better village, I would say, well established. And I went to when I was a 7th grade or something like that, to his home, and I completed a high school staying in his home. And then I went to the college. That is where major shift from village side to the college. It is a big town. When I went to the undergraduate degree, at that time there is a pre-university and then you go for undergraduate degree. I did not feel anything different since I was always away from home. I did not feel like, hey, I am missing them, missing this. I just visit my home whenever holidays comes and spend some time with my brother and sister and parents and relatives and go. Since I am studying well and everybody respect me, everybody listens to me, that's the case always in the village side. So yes, I did not feel much difference. Even if I came to this US, I did not be much difference even in the lab because IIT Madras works exactly like all the Western countries' institutions. All the IIT faculty members are graduated from, are trained from some other country, Western countries, things like that. So the working habit is the same as I do here. There is no end. So I always continue my work as I was a PhD student.
So that was the work side of it. What about culturally? When you came to the US, I know I've asked many guests who've gone over to the US or US coming to Europe or over to Asia or Australia, wherever it is, how they found the cultural side. It's just the living side, find the housing, the change in housing, the buying food. I know some of the UK people who go over to the US terribly miss British chocolate, because I'm sorry, all you US, British chocolate is so much better than what you get in the US. How did you find those cultural changes when you went over?
Well, when I was in the high school or undergraduate degree, I was in the NCC, National Cadet Corps. There, they will teach you how to cook. Okay, so when I came to this country, I was cooking myself, basically Indian food. So with the spicy, everything is available. I did not feel any different that I am hungry, I don't know how to eat, I am not vegetarian, I can eat anything except cow meat. So I eat everything. So fish and chicken, things like that. So I did not have any problem when I arrived in this country. And my postdoctoral advisor was very, very supportive of me. And he made me feel at home. So I was very, very happy. And food-wise, not an issue for me. And adjusting with the people, yes, there was an issue, trying to, as you know, in India, you give respect to the elders, whatever they say, even it is wrong, you listen. Sometimes you don't think everybody is honest. And it took me some time to learn. My postdoctoral advisor told me, look at the fingers. All are not equal, right? Don't think everybody is like you. So,
do you still cook at home? Are you still the main?
Yes, I still cook home. No problem for me. Still, I am cooking.
And are you the main cook?
Yes.
Yeah.
Yes.
You've just taken one of my other questions that I have later. Okay.
Okay, that's fine.
So, thinking about you came to the US, you've made your name. What drove you to get so involved in SPIE and the conferences side of things?
My first paper was published in SPIE when I was a graduate student at IIT Madras. So I used to attend whenever I get a chance, since I am using all optical methods. And the SPE is the idea. I kind of found it's very ideal for me. I used to go for a Biophysical Society meeting too. Every year I used to go. Once I started my workshop, it so happens next following week, Biophysical Society meeting in March. I can organize my workshop only first week of March, spring break, no students. I can take the whole floor to do that. So the SPIE meeting, I go whenever I get a chance. But once I joined in University of Virginia, it is kind of my own lab and everything. I make the call. So I used to go every year. And one day I was sitting there. I was just presenting my data. Even Tony Wilson conference, I used to do that, microscopy conference. And one day I was sitting there. Joe Lokovich came to me. And he knows I am running a workshop. I am from University of Virginia. He has a lot of respect for University of Virginia faculty members. I was sitting there. He came to me, and he brought one SPIE manager or whoever, technical manager or something like that. He is the guy. You ask him to run the multiphoton microscopy conference. So that's how I started. I asked Peter So to join with me to start a conference. And Ward Webb was so excited. He was the first speaker, keynote speaker for the conference organizing this. He was so supportive of that. And all the microscopy company supported the conference. So I was able to run it. So that's how I got involved with the SPIE. It's a lot of interesting stuff on the technology side. applying for various applications is so exciting to me. I attend many sessions. I usually, in addition to my conference, I used to go for selected talks.
What year was it that you started your involvement there?
Pardon me?
What year did you start your involvement with SPIE in organising the multiphoton sessions? When was it?
I think it was 2001.
So that was really when biology started to embrace multiphoton.
It really was
that time that it started to get a bit.
1999. Bio-Rad started marketing this multiphoton microscopy. In 1998, I got a NSF grant to build a multiphoton microscopy. At that time, there is no commercial unit, so the federal government gave the money. Then 99, 2000, it became a multiphoton microscopy commercialization of Bio-Rad. In 2001, it was very timely. Joe Lockovich asked me because when he started the JBO, Journal of Biomedical Optics, he requested me to be one of the editorial board member. That's how he knows me. I joined in the meeting 97. I remember that 97 or 96, he started the JBO. So he asked me to be a member. I think I joined in 96 or 97. He knows me well. So that's maybe one of the reasons why he asked me to organize the multiphoton conference in 2001.
Which is now expanded, because that now includes FLIM and other aspects in the talks that were around it. So the technology's moved on from that.
Yeah, I included not only multiphoton microscopy development or applications, and also FLIM FRAC FCS, which is 2-photon, is used a lot for FLIM. And now I included for the last 3 or 4 years metabolic imaging, NADH, FAD, and tryptophan, which we are using a 2-photon microscopy excitation. And also, when I started, I also include the CORS microscopy. Sanishi came and requested me, hey, why don't we start a session in the multiphoton microscopy on CORS? I said, yes. Then it became a one-day session in my conference. It became from 3 days to 4 days. Then I told the SPIE people, you should give him separate conference for CORS. Now they are running a separate conference, not in my part of my conference. So this is how all the, whichever multiphoton involved, the applications was included in my conference. Now we have only FLIM, FRAC, FCS, and metabolism. And also I run once a year some special. For example, last year I ran women in multiphoton microscopy. That became very attractive. They started running news in the SPIE, almost all the journals. And the next year, going to start on FRAC, FLIM, FCS, and metabolic imaging as a special session. In that, I invite some keynote speakers and things like that. I also sometimes invite plenary speakers for Sunday. When Stefan Hell, Eric Betsick, William Moyner won the Nobel Prize, the following November, the following next year, January, I invited them to celebrate celebrate the super resolution microscopy. So they were 3 of them are there. And next year, also they asked me to organize a plenary speakers. On Sunday is always plenary. It's common for everybody. So I invited Nobel Prize winner 2023 from MIT on quantum dots. So he agreed to come. And I had to find another speaker because we need at least 2 speakers minimum. So I am still looking for another speaker to invite.
Well, I think you've gone through half my podcast guests. Won't go through WE, Eric. You mentioned Tony. Petra Schwiller, of course, obviously not WhatWeb, but Petra Schwiller from WhatWeb's lab. So Petra, there's a good idea for you.
Yeah.
She's quite inspirational. I'm going to take you back now. What was your first microscope that you ever used? Can you remember?
In Seattle, I built the microscope, buying all parts, everything. The first microscope I used is Nikon.
Okay.
Yeah, I built. I at that time in Chapel Hill, I have Olympus. It is a kind of facility, and we had a Olympus, Zeiss, everything. But I used the Nikon to build the fluorescence lifetime imaging microscopy as a basic.
So now you have lots of microscopes because you also have the Keck Center for Imaging. So I have a question on this one. So it's the Keck Center of Imaging, or for imaging rather. So this, I presume, is funded from a philanthropist at this point, or a foundation set up in their name?
There is a story behind that. I was in Chapel Hill. I developed the fluorescence lifetime imaging microscopy. At that time, there is no lifetime imaging. I developed it for calcium signaling using gating camera. The gating camera was given by Hamamatsu, free. It is free gating camera. We got only money for buying a laser, neodymium YAG laser based dye laser system. I have everything, second harmonic, third harmonic, and dye laser systems. So that is where I built the lifetime imaging system at the time. And then, of course, Hamamatsu free gave the camera, but they used the idea to build a streak camera. You made a lifetime streak camera. It's all based on from our work on their gating camera. Now gating camera is available 100 megahertz. At that time, only 10 kilohertz repetition rate. So I was in the Chapel Hill. Then I got the invitation from here. They told me some microscopy company told, hey, this guy is good. Why don't you invite him to start a microscopy center here? So that's how I came here. The VPR was very, very interesting person, meaning that he always interested to introduce new techniques, new technology for biological investigations. So he helped me to get money from the Keck Foundation. It's about $1 million at the time, 98. So that's how this center, they told me, you spend the money as you like. You just name this. At that time, I started as a Center for Cellular Imaging. Then Keck Foundation money came in. We started as a Keck Center for Cellular Imaging. This is how the Keck Center was founded by money from the Keck Foundation. And using that money, I generated millions of dollars from NIH, NSF, other organizations. This is how the Keck Center now equipped with, you name it. We have all kinds of microscopy. Not only commercial, I built the microscopy system, mainly two-photon lifetime imaging system. I built the tough system. These are all custom-built system is available. And since I am teaching the microscopy course, the students really enjoy how the custom-built microscopy was done, and they wanted to involve, they learn about it, etc. So this is how I started the Keck Center for Cellular Imaging. And the university was supporting in every aspect of the operation.
And do you still get funding from the Keck Foundation?
No, they give only one time.
Okay, but
only one time.
But it was a big time. But that's what set it up and got it going. And they
exactly. That's the Keck Foundation that's their motive. They give the money to start something new idea for a particular institution, and then they expect the institution and the investigator should expand And Keck Foundation was very, very happy.
Okay. Actually, no, I've got to go back. What was the during your career? What would you say has been the toughest time during your career?
The first time in the academic life, always getting grants, right? That is the toughest time for sure. I faced with most of the time. That was I consider as the toughest time, getting money and sometimes fails, and again you have to resubmit and get the money. And running the lab research-wise, I was lucky to get many postdoc students, very enthusiastic to work with me, and so the toughest time I would say mainly getting grant money, make the people to work, to stay in the lab, so that I never asked them anybody to leave, but most of them, they work and then get a job and they go. That's how it works. And most of them work, particularly postdocs, was for 6 years. So they really helped me a lot to establish the Keck Center. I would say the toughest time is getting money.
Okay, so you didn't get the money, the grant is rotten. When you go home, what do you do to relax? What do you do to chill out when you get home?
I go to the pool. Swimming pool. I go to the swimming pool.
How often do you swim?
Yeah, that is where I relax, really. Tell you the truth.
And how often do you swim?
Every day.
Every day?
Yeah. My gym is just behind my building.
Okay.
So
no
excuse.
How long do you swim for?
I go to the gym. I tell them 4:30 I leave my office. If anybody wants to talk to me, I tell them come to the gym. And I spend for 2 hours gym activity, and then I go for swimming.
That's a long time.
Yeah. Use different equipment, at least 1 hour on the gym and 30 minutes for swimming and things like that.
So does that mean you pause at the end to enable people to ask you questions, or do you just go backwards and forwards?
It happens. One time, one of the professors came to me, "Hey, the Keck Center door is not locked." I was swimming. He came and he's a senior professor in the biology department. He was sitting there. I wonder why he was waiting for me. I went there, hey, the Keck Center door was not locked, and you better watch out. And he said, okay, I will check on that after I return. So, yeah, usually they come when I was in the gym. Yeah.
And I do have to ask, I'm also a keen swimmer. Are you a front crawl or breaststroke?
Pardon me?
Are you freestyle swimming, front crawl, freestyle, or breaststroking?
I do everything, all swimming, freestyle, breaststroke, and everything I do. Backstroke. I mix everything.
Butterfly as well?
Butterfly, I have not done. No.
That's.
I found it a little tough, but I did not do it. Butterfly, but breaststroke, all those things I did except butterfly.
So that's what you do to relax. Have you got any other hobbies outside of that?
No hobbies. I don't. My gardening is my hobby when I go home.
Oh, that's a hobby.
Yeah. All the vegetables I mostly do not buy.
Yeah.
It's all from my garden. Pepper, eggplants, beans, tomatoes, everything.
So if that's what you've got, we've talked about the tough times of not getting a grant, how you chill out. What about the best times at work? What has been the best time in your career? If you could relive any moment in your career, what moment would it be? Or period?
Well, in research, when you get your results successful, you are very, very happy. So that's where I always excited whenever things worked. You struggle hard, I try a number of ways. When it worked and you are so excited, I really take my group to the lunch. Let's go. Paper accepted. So this kind of exciting, mainly research, I would say when I was very much excited when I did the tryptophan imaging, amino acid. No imaging was done at the time. Tryptophan emission is in the UV. All the microscope, the tube lens gives only after 400. You don't use the microscopy to do the imaging. So I was having at the time biorad 2-photon MRC 2000. So I built myself taking the signal from the below the non-D scan, below the objective lens, and then I put the detector, which is UV, lifetime detector. You got the image. So that was very exciting moment for sure. Nobody has done on tryptophan imaging at that time. It is 2012. I did that experiment. That's how I started involving metabolic imaging after that.
That's a good standout, mate. I was going to ask if you could pick out any one standout result, and you've just picked that out quite nicely.
Yeah, recently, I have a completely new invention on the biopsy screening. Biopsy tissue screening, cancer tissue or any tissue, they use the grading using gliation, right? Gliation grading.
Yeah, for prostate
you
cancer.
require tissue development, staining, and everything. But lifetime is a fingerprint of the molecule, right? So at the molecular level, you can detect whether it is a normal cell or cancer cell. The cancer cell lifetime decreases. So that gave me an idea that we can detect early without staining using the NADH imaging. No staining, you just use the NADH imaging, autofluorescence, use the 2-photon excitation, and you can easily, the HNE staining says normal, but our lifetime technique says there is a lot of cancer cells. So now it is a US patent, patent that I am working with a company to build the clinical system to test in the clinical area. That is really, after working so many years, I felt like, this is something I am contributing to the society. This is early detection, not only early detection, it's a better method. You just take the biopsy tissue, put it on the scanner, and use the machine learning software. It spits out the data, grading technique. So that is very exciting for me. This is very recent one.
It's interesting you say about the machine learning. We've been looking at similar strategies, not using multiphoton, but machine learning for learning more about the samples that are otherwise not easy to extract information. How big do you think machine learning is going to be, and AI part of that going forward in microscopy? Just general biological research.
Well, if you want to use the machine learning, you should have a large number of data to do the data analysis. I always say this artificial intelligence is a black box. We are creating a software to do what is necessary for us. So the huge number of data, thousands of data points, if you take a 512 by 512 pixels image, if you wanted to take each pixel, gives the lifetime distribution. So you get huge number of data points. If you want to do it statistically, this is a very good machine learning approach. It's a very good approach. You get it within seconds. For example, we submitted a paper recently in the scientific reports. I revised and resubmitted 3 weeks ago. That paper is focused on the drug cellular response. Our ordinary method data analysis showed it takes 60 seconds drug response. But when we put all the data points in the machine learning software, it says you see the drug response within 15 seconds, not 60 seconds. So the data crunching, data analysis, the machine learning approach is really, really useful. This happens. Yeah.
Yeah, I think once AI can start telling us what the features are, that'll be even more useful. As you say, at the moment, most AI is just a black box, but once it can actually extract information and tell us what it's extracting, tell us what it's found, because that at the moment is obviously a missing point. Flow cytometry has a lot around there's a few instruments now based around machine learning and AI, but it's a leap of faith when it's not telling you what features it's identifying to identify subpopulations, for example. And I think that's, as you rightly say, as you've been going with the Gleason grading, is by using your machine learning, it's informative, and you've got confidence in you know what you're extracting, you know what features, it makes sense. It'll be interesting to see where it goes.
Yeah, it's it is an interesting discussion always on the machine learning approach. As I always say, it is a black box. Only thing we write the software to incorporate all these. You follow their instructions, methodology, how to input the data in their algorithm, and then it spits out the data. And your question is, how do you believe it? Whether that data is right or wrong? We have a person who does the job. His name is Host Rabi. He is retired from the pharmaceutical company Bayer, and he has been working with me for a long time. And he likes the numbers, so he don't believe the software. He don't believe the machine learning. He does it himself, calculate, and comes out and say, "Yeah, I believe it now. It gives me the same results what the machine learning is giving me." So yes, it is difficult to say, pinpoint how the machine learning works, but you are always looking at the output results, whether it is correct or not correct.
So it's interesting how you've picked out the lack of trust and the building of that trust. And actually, one of my questions I was going to ask you, in those early days of multiphoton, and think about when the first multiphoton laser came out and first being used, how difficult was it to get acceptance of that as a technique in the life science community?
That's a great question. Yes, it was a tough time. I built myself, as I mentioned to you, with the NSF money. At that time, there is no commercial system. This is the only multiphoton system we had in the university. So they wanted to do calcium imaging using Indo1 and other applications such as FRET and lifetime, etc. So it is, even in lifetime imaging, it is difficult to convince the biologist how to interpret the data. So that's where the whole issue comes in the picture. I am interacting with the biologist a lot, number of applications, cell biology, neurobiology, developmental biology, you name it. Everybody comes here and asks me, how can I do this? And I do explain in length how to do that. And if the students comes, ask them to take my class. I will explain more in detail and train you in the microscopy how to do the calcium imaging in neurons or in cells, anything, or developmental biology, embryos. Yes, it is, if you do not convince them that the microscopy technique is useful for their investigation, seeing is believing. So you should see it. And I work with them, or my staff will work with them to make sure that they see the right results. Then they are excited. And they do see some people are publishing data in their own science field. Why not I? So I told them, okay, come on in. We will figure it out and set up the system. and make sure you get the right results. That's how you can motivate the biologist to use the microscopy system. And you have, for example, for FRET, I have to demonstrate, I have to publish, then only the biologist will come, okay, I will spend my time doing FRET. If you do not, yeah, go ahead.
No, I was going to say, actually, so thank you for many of us, because we didn't have to do that. Because when we started doing FRET, it was still, FRET goes back to the 70s. Biochemical FRET goes back way back, but imaging FRET, a lot of those methods were not really, they were very challenging on a microscope back in the 90s. It wasn't really until the emergence of the improvement of piezo controllers, the AOMs in microscopes, that enabled us to really move forward in confocal side and make it available to the masses. But it's because of that prior work that yourselves have helped develop that meant actually users were more willing to accept it straight away. So, you know, it's made life a lot easier for biologists to trust it. And maybe that's where machine learning will go in the future. I have some quick fire questions for you.
Okay.
Okay. So are you an early bird or night owl?
Nighttime.
Okay. PC or Mac?
PC.
McDonald's or Burger King?
Pardon me?
McDonald's or Burger King?
I don't go at all. Rarely I go McDonald's. Very rare. If I travel. Yeah.
If you're forced to. Coffee or tea?
Tea.
Beer or wine?
I drink only wine. So this is my tea.
Okay. Which looks like beer in that
green tea.
So you drink red or white wine?
Red.
Chocolate or cheese?
Chocolate. I don't eat dairy product that much.
Yeah, okay. Dark chocolate rather than milk chocolate then?
Dark chocolate.
Yeah.
Daily one piece.
If you were to cook you said you cook, what is your signature dish? What's your favorite food to cook?
Chicken.
Chicken what though?
Chicken with spicy, yeah.
Just spicy chicken with rice, with
rice, yes, with rice.
Okay. What is your least favorite food to eat?
Least favorite food? I don't know. I only cook what I like.
Okay, so if you were to go to FOM and you were taken out for a dinner and you didn't get to choose a menu, it was just the menu is going to be given to you. You have no choice. What is the worst food that someone could put in front of you and you go, oh no?
Whatever cheese involved, it is. I don't like it. Yeah.
Okay.
Yeah.
TV or book?
I watch TV news. Yes.
Okay. So did you watch any trashy TV? I remember asking Richard Henderson this, and he said
no. Mainly news.
News.
So I turn on news. That's it. I don't watch TV much.
Okay. Do you have a favorite film? Favorite?
Movie?
A favorite movie?
I watch only movies, comedy movies, not serious drama or anything.
Yeah.
Whatever related to comedy, I really watch. Even in the flight, I watch only comedy.
Do you have a favorite one?
Favorite one, many things I can say. I really like the guy. What is his name? I forgot. The Threes Company, not Threes Company. I really, the name is not coming to me. I was surprised.
I'm no good at actors' names. I also like comedy films, but don't ask me who the actors are. I could watch films again a second time because I forget what happens. In a moment,
I watch basketball game for sure, and I watched the finals just last night. Dallas Mavericks versus Boston Celtics. So I usually watch basketball game for sure.
So do you support a team?
Uh, I like Los Angeles Lakers. I was watching for Magic Johnson for a long time, Magic Johnson and Larry Bird. And after that, I did not watch that much game, but I watched the finals.
Okay.
Yeah.
And you say you don't read books, or not often.
I don't have time to read the research article. I love to read research article or something. I read book about the scientist, what they did. For example, Einstein and all those famous people, Bohr-Nielsen, you name it. All those historical, their background, how they became a scientist. I was always interested to read those kind of books for sure. I have a number of books in my home like that. Yeah.
Star Wars or Star Trek?
I did not watch those movies. Sorry.
Well, that's okay.
Yeah.
India or the US?
Well, I love working here, but you miss your family and friends. So I go every year to India. I am teaching over there actually. Now, no, they cannot come for my flood workshop. It's a lot of money we have to spend. Now they told me, you come here, we pay your ticket. You come here and teach us. So I started last year, and this year also I am going. So IIT Madras organizing the flood workshop. And I go there and, of course, visit. A lot of my friends are there still. Now India is like a foreign country for me. I can get things done here many number of ways than in India because I don't know anybody. So
how do you find the cultural change now going from the US back to India?
That's usually I don't go in summertime. I go only in November or December. It is hot. Even when I was there, I did not go outside at all. My room is always air conditioned lab. So I always stay there. IIT Madras is close to the ocean beach. Evening time, I go out. Until then, I stay in my lab. I work hard. I completed my PhD degree within 3 years. I mean, thesis and everything within 3 years. So I work hard. I am continuing to work still the same way. All the time I work.
When you retire, will you carry on working?
I don't know what to do if I retire. I don't know when I retire. Everybody asking the question. But I am still working like a student. So I don't know. No idea.
The impression of someone who's going to just walk away one day and do something else. You don't give me that impression at all.
I did not think about it. And if you think one day you wanted to walk away, you will be wondering what to do next without a plan. Usually my personality is that without a plan, I will not step out of my home. Even if I travel or anything, I know ABCD where I am doing every day. So without a plan, I never step out of my home. Even when I traveled in many countries. Conferences, meeting, invited talk, and etc. I always planned everything so that my travel will be smooth. The same way, everything. Even when I come to work, what I am going to do today. So that's how I work. So I really do not have an idea what I do after my retirement. As you know, here nobody asks you to retire. Here you can work as long as you want. So I'm just continuing. So far, I did not think about it.
One last quick question. What's your favorite color?
Blue and white.
I thought you might have said tryptophan UV or far red, but okay.
That's a good idea.
I could have said anything with a 2.2 nanosecond lifetime. It would have fit as well.
Yeah.
We talked about inspirations. Finally, we are coming up within 5 minutes of the hour. Do you have any regrets in your career?
I did not see any regret. I would say that my family complained that I am spending a lot of time at work. So probably I should have spent more time with them. And, when you think that you want to spend your son, he is gone. So that's...
regret that?
Pardon me?
But do you regret spending that much time at work?
Yeah. Regret not spending much time at work. No.
Do you regret spending that much time at work and not seeing so much of your family, or actually have you justified that to yourself that actually, no, this was the right thing?
Well, one of my senior told me that, if you do what you love both your family and your work. But you have to balance the time for both, for sure. That's what I am doing. Try to do, but more time for sure at work.
And then families following sort of in your footsteps. They've all gone scientific. They've all gone on to academia. So they've been inspired, I would argue, with...
Yeah, that is true. They follow me too. Yeah, so they see that how much hard I am working to achieve anything. When I edited my first book, my daughter was in the high school. She edited my preface for the book, English.
Mm-hmm.
Oh, your English is not good. So they enjoy what I am doing. No question about it.
One, I didn't ask. I asked what you wanted to be when you were young. You were very early driven to be a scientist. Obviously, you went on to science and physics and to answer the biological questions using your physics to develop technologies to help address problems, and critically looking at what you're doing with cancer now, making quite a fundamental impact. But if you could sample any job for a day or a week, any other type of job in the world, what type of job would you like to experience? Not as a career, just as a day or a week, to know what it's like to be that type of career or that type of person.
Well, if you like me to say, I would like to do farming.
You like farming?
Yeah, I came from the farming. I know all the farming. I worked once my father was sick for 6 months.
Mm-hmm.
The whole crop, I did about 20 acres of land. I was only maintaining, and also going to the college. So coming every week and trying to manage that. My father cannot do that at the time. So at that time, I learned a lot. I love farming, but here I am not doing. If I go back, still my lands are there. My brother is taking care of it. But that's a very good point. I am still thinking just to go back after retirement.
That's cool. So you must have enjoyed that time, even though it sounds really stressful on a personal level and just a learning level and educational and work level. That must have been very intense. But it sounds like that was good memories.
Yes, because of the young age, I involved in farming a lot. When I was an undergraduate student, I still love it, what I did. Yes, maybe that's a good idea. I should go back after retirement. I probably enjoy.
I think I've often compared scientists to farmers, and the way that we research different fields, we have different crops in different fields and rotate them around to be successful. And you have your main crop and try to very similar analogies and probably similar work ethic, that it doesn't stop. It's all year round.
Yes, I agree with you.
Ammasi, we are up to the hour. So I'm going to say thank you very much for chatting to us today and sharing so much about your childhood as well, which has been amazing to learn. It's something that you can't really read about. Thank you everyone for watching, listening. Please do subscribe to whichever channel you're listening this to. And you've heard Ammasi talking about Stefan Howell, W.E. Myrna, Eric Betsy, Tony Wilson, all previous guests on here. So go back, listen to the back catalogue. But Ammasi, thank you so much from the scientific community as well. for everything you've done in developing the technologies, but also delivering the content and the courses in the past as well around threats, and contributing through the listserv, answering questions and helping people across the world with really fast responses. We've been really helpful to us all. So Ammasi, thank you very much.
Thank you. I enjoy in training others what I learned. That's why I love this job.
Thank you for listening to The Microscopists, a bite-sized bio podcast sponsored by Zeiss Microscopy. To view all audio and video recordings from this series, please visit bitesizebio.com/the-microscopists.